And this question has something that we haven't seen yet. So it's going to be spaces strategy still, but we haven't seen any questions with a restriction. So we've had spaces questions where we fill in our spaces, but this is going to be a spaces question with a restriction. Okay? I'm going to use how many 3-digit numbers just to make it a little bit more interesting. I'm only going to use the numbers, and you can add this to yours, using only the numbers 1 through 7. How many digits are even? And you're not allowed to repeat a number. So there's a restriction that the number has to be even. And the strategy that you're going to use is to deal with the restriction first. And I'll show you why. Let's say we make our 3 spaces because we have 3 decisions to be made. And we start with the space on the left side because we normally work from left to right. Okay, we say, well, there's 7 numbers. How many choices would I have here? 7, right? Then how many choices would I have next? 6. And now I have to decide how many choices I have for my last one. This is the restriction, right? This number has to be even. How many choices do I have to have there? 3. Okay. But what happens when I chose my 7 if I had picked a 2? Then I don't have 3 choices left because the 2's already gone. Then I'd have 2. But what happens if in my 6 I also chose the 4? Then I would only have 1 choice left. So it becomes a problem because if we choose this 7 and 6 first, we don't know what we've chosen. We might have already chosen an even number, but we might not have. So we're left with this is either 3 or 2 or 1, and that doesn't really help us with multiplying. We can't go 7 times 6 times 3 or 2 or 1 and get the right answer. So instead of running into that problem, we say, what would it look like if I put my number in the restriction first? If I said, I have 3 choices there, it has to be an even number, 2, 4, or 6, right? I make that decision first. That will guarantee that my number is going to be even. Now, how many choices do I have left here? 6, because I've only used up one of those even numbers. It might be the 2. And if I use the 2, then I still have 6 choices left for my first one. It might have been the 4. If I'd used the 4, I'd still have 6 choices left. Or it might have been the 6, in which case I'd still have 6 choices left. Can you see by putting the 6 there, I still might have an even number there. And it still gives every single possibility for every number could be first. But just one of the even numbers, 2, 4, 6, is for sure at the end. And now I've used up 2 numbers, so how many are left? 5. So there's going to be 90 ways. So this is a new strategy that we're going to use within spaces. If you have a restriction, you're going to have to count that restriction first in order to figure out how many would be even. So I'd like you to do this one for how many are odd. Try it first on your own, and once you've solved it one way, see if you can find out another way of solving how many ways that there are odd. So most of you probably did exactly what we did before, which was say this is odd, that's my restriction. How many odd numbers there are if I use 1 through 7? There are 4 of them. I used up one number, 6 left, then 5 for 120. Another way of looking at this one. If we think about all the 3-digit numbers with no restrictions, would you agree that that would be 765 for 210? And we figured that out earlier in the question before. If there are 90 even ones, what would we have to do to figure out how many would be odd? Subtract. So if I go 210 minus 90, I get 120, which is odd. This is an example of another strategy that we're going to use in this unit. Sometimes it's going to be easier to count the bad ones, or the ones you don't want, than it will be to count the ones you do want. In this case, it was easy to count the odd ones directly on their own, but sometimes it won't be easy to count something directly, but it'll be easier to count the bad ones. And if you take all the ones and subtract all the bad ones, you're going to be left with what you want, I guess the good ones, that'll be left. So this is another strategy that we're going to use. I call this one the not strategy, N-O-T, because you count something you're not supposed to and then subtract it from all of them to get what you want. That's better than calling it a bad strategy, because it's actually a good strategy to use. One more question, and then we'll end here. How many 3-digit numbers can be created using 0 through 9 without repetition? There is a restriction on this one. Got 3 digits. There's no repetition, but what is the restriction? Can't start with 0, because then it will be a 2-digit number. So how many choices do we have for our first one if that's our restriction? 9. Because there are 10 digits including 0. Then, now that you've picked either 1 through 9 for the first one, how many choices do we have for the second one? 9 again, because 0 gets added back in. Now you've used up 2 numbers, then it would be 8. And this would give you, I think, 648.